Hey folks, Mike Rowe here. Today we're diving into a good old-fashioned manufacturing process that's keeping your showers steamy and your dishes sparkling clean water heater rod production. It's a process that involves bending steel, weaving wire, and a whole lot of heat. We're going to break down the entire operation, from the raw materials to the final product. Get ready to get your hands a little dirty. So, let's get down to the factory floor and see how these essential home appliances are made. Get ready for a behind-the-scenes look at the making of a water heater rod. Before we fire up the machinery, we need to gather our ingredients. First up, we've got steel pipes. These form the backbone of our heating element, providing structure and durability. Next, we've got nichrome wire, resistant to heat and corrosion, perfect for carrying the electrical current that'll heat our water. We use magnesium anodes to protect our steel pipes from rusting away. These sacrificial lambs attract the corrosive elements in the water, extending the life of our water heater rod. Finally, we've got the outer casing, usually made of plastic or metal, which provides a protective shell for all the internal components. With our ingredients prepped and ready to go, it's time to fire up the production line. The heart of our water heater rod is the heating element, and building it is a multi-step process that requires precision and care. First, we take our steel pipes and bend them into shape using mandrel bending to create a uniform coil. Steel rods are welded to the coil, providing extra support and rigidity. To protect our steel coil from corrosion, we coat it with a special ceramic enamel. This protective layer acts as a barrier between the metal and the water, preventing rust and extending the life of our heating element. Once the enamel is applied, we bake it in a furnace to ensure it's tough and durable. With our heating element prepped and ready, it's time to add the spark that brings it all to life: the nichrome wire. This wire is the heart of the heating element, converting electrical energy into heat through resistance. The nichrome wire is carefully threaded through the ceramic-coated coil, requiring a steady hand and a keen eye. This step is crucial as it ensures the wire is evenly distributed, which is essential for consistent heating performance. We use special insulating materials to prevent the nichrome wire from coming into contact with the metal components, ensuring that the electricity flows safely and efficiently. These insulators are designed to withstand high temperatures and provide long-lasting durability. The process of inserting and insulating the nichrome wire is a testament to the skill and craftsmanship of the workers on the production line. Each step is performed with precision to maintain the integrity of the heating element. They work with meticulous care, ensuring that each water heater rod meets the highest standards of quality and safety. Quality control is a critical part of the process, involving rigorous testing and inspection. It's a job that requires patience, precision, and a deep understanding of the materials and processes involved. The dedication and expertise of these workers ensure that every heating element functions flawlessly, providing reliable and efficient heating solutions. Our heating element is almost complete, but we're not done yet. There are still a few critical steps to ensure it functions safely and efficiently. We need to connect it to the electrical wiring that will bring the power from your home's electrical system. This step is crucial, as it ensures the heating element receives the correct voltage and current. The ends of the nichrome wire are carefully connected to the electrical wiring, ensuring a secure and reliable connection. This meticulous process helps prevent any potential electrical faults or hazards. But before we button everything up, there's one more crucial component we need to add: the magnesium anode. This small but mighty piece plays a vital role in the longevity of the water heater. The magnesium anode is attached to the heating element, and its job is to protect the steel tank from corrosion. Without it, the tank would deteriorate much faster. The magnesium anode is made of a more reactive metal than steel, so it attracts the corrosive elements in the water, sacrificing itself to protect the tank. This sacrificial process is essential for maintaining the integrity.
The manufacturing process of calculators in a factory involves several stages, from design to final packaging. Here's an overview. 1. Design and planning. Prototype development. Engineers design the calculator, including its size, shape, button layout, and functionality. Component selection. Key components like microprocessors, LCD screens, batteries, and casings are identified. PCB design. The circuit board layout is designed using specialized software. 2. Component manufacturing. Microprocessor fabrication processed at specialized semiconductor facilities. LCD screen production involves layering liquid crystals between two thin sheets of glass. Plastic parts injection. Molding. The casing and buttons are molded using plastic resin. 3. PCB assembly. PCB manufacturing. Printed circuit boards, PCBs, are fabricated and printed with copper patterns. Soldering components. Surface mount technology, SMT, and through-hole components are soldered onto the PCB using automated machines. Quality inspection. Each PCB undergoes electrical and visual testing for defects. 4. Assembly line. Screen integration. LCD screens are attached to the PCBs. Casing assembly. The PCB, battery compartment, and other components are fitted into the plastic casing. Button placement. Rubber or plastic keys are fixed into their positions. Power supply, batteries or solar cells are added. 5. Testing. Functionality tests. Completed calculators are tested to ensure all buttons, displays, and features work properly. Stress testing. Durability and reliability are tested under simulated conditions. The manufacturing process of an abacus in a factory involves several stages, combining traditional craftsmanship with modern manufacturing techniques. Here is an overview. 1. Design and planning. Blueprint creation. The design of the abacus, including the frame, rods, and bead dimensions, is finalized. Material selection. Materials such as wood, metal, or plastic are chosen based on the type of abacus, e.g., traditional or modern educational. 2. Material preparation. Wood processing. Logs are cut into planks for the frame and rods. Planks are sanded, shaped, and polished to achieve a smooth surface. Plastic molding. For modern abacuses, plastic components are molded using injection molding machines, metal rods. Metal rods are cut and polished to required lengths and diameters. 3. Bead production. Shaping. Wooden beads are carved using a lathe machine. Plastic beads are produced using molds. Finishing. Beads are sanded, painted, or polished to enhance appearance and durability. Drilling. Holes are drilled in the beads to fit them onto the rods. 4. Frame assembly, frame construction. Wooden or plastic pieces are assembled to create the abacus frame. The frame is glued, screwed, or joined using precision tools. Rod attachment. Rods are inserted and fixed into the frame, ensuring alignment and durability. 5. Bead assembly, bead stringing. Beads are threaded onto the rods. Rod ends are sealed with caps, glue, or screws to prevent the beads from slipping off. 6. Quality control, alignment check. Rods and beads are checked for smooth movement. Durability testing. Frames are tested for strength and stability. Aesthetic inspection. Paint, polish, and overall appearance are inspected.